Algebra 2, section 14.4, the law of sines. Before I actually do the couple of examples using the law of sines, let me just quickly tell you that there is an example prior to the law of sines examples in this section that deals with area of a triangle given side angle side. This is not a topic we're going to cover, just to be a little bit more brief. This was covered in your geometry class anyway. If you want to take a quick look through that in your book, you may. None of the Khan Academy questions will pertain to this either. The law of sines is a way to solve on a triangle that's not a right triangle. You may recall the Pythagorean theorem, which is not a topic in Algebra 2, but has been in classes you've taken prior to this one. And the Pythagorean theorem, though helpful, is very limited. You have two sides, and you can find the third side on a right triangle, and that's it. It says nothing of angles, either given or wanted, but just two sides have to be given on a right triangle, and then you can find the third side. That expands a little bit more into the last lesson, 14.3, that you can solve on right triangles and different information is given. Well, this is the next logical step in that, is the law of sines, where we can solve on a triangle that's not a right triangle. Now we're going to do just a couple of examples. Before we do that, you need to know that the way we label triangles is, if I label this triangle ABC, the side that's opposite vertex A, that we use capital letter for, is going to be lowercase a. The side that's opposite capital B vertex is lowercase b. That's the side. Again, in geometry, you might have called this segment AC, like this, AC, with a segment symbol over the top. Well, it's easier to just refer to it with a lowercase letter, and we just use opposites to do that. Here's capital C. This side is lowercase c. That actually came into the previous lesson as well, section 14.3 a little bit. So I should have mentioned that in the lesson. I didn't really think about it. Let that help you if you got confused on any problems like that. Also, regarding the naming is, we have to use some letters, right? When we give you the law, we have to use some letters. Again, let me just use Pythagorean theorem as an example. A squared plus b squared equals c squared. Well, does that mean that any triangle that you can solve on using the Pythagorean theorem has to be labeled ABC? No. Any letters will work, right? Basically, as we look at the law of sines now, the sine of capital A, that's an angle, and it's over lowercase a, which is the side opposite that angle, is equal to the sine of B. Capital B is an angle, lowercase b here is a side length. And what's true with the law of sines is that these three ratios are equal. This is true. I crossed it out in red because it's just not needed. We're not going to solve anything using three fractions. We're just going to solve a proportion, which is two fractions. Okay, so let's look at a couple of examples. That's the area example. Again, we're not doing that. But here's a law of sines example. And if you have to, you draw the triangle. Here's a triangle already drawn and just labeled with the information given. And they want us to find the length of AC. Now they call it AC. I'm going to call it lowercase b. Capital A, capital C, the length. By the way, what I mentioned to you a minute ago, I said AC with the segment over the top. That's its name. Without a symbol, without any symbol, if we just say AC as they are here, just AC, that's a length, okay? But again, they call it capital A, capital C. I call it lowercase b. That's the length of this segment. And the law of sines would have me to do this. The sine of 33 over 8 is equal to the sine of this angle over b. Now, that angle is not known. What you need to have, first of all, to use the law of sines, what you need to have is what I often refer to as linked data. Here's an angle, here's the side opposite, and I know both values. You have to have that to use the law of sines, okay? The second thing you need to have is another value. And if we're trying to find lowercase b, I would need to know this angle right here, okay? I would need to know what capital B is. And we know that the angles of a triangle do add up to 180. So if I take the sum of 33 and 64 from 180, it's 83. That's another value that I need to have. Okay, now not every problem will be like this, but you may need to use the triangle angle sum theorem, the knowledge that the three angles do add up to 180 in order to do this. So the rest of my work here then is sine of 83 over b. Okay. Now, anytime we're given a problem where it's fraction equals fraction, we always cross multiply. So what that would look like here is if I cross multiply by multiplying these two values and then these two values is b times the sine of 33. You'll find that I always like to put my variable on the left. Okay. Whether it's an angle or a side length, I always put it on the left. Doesn't matter. That's just a preference. It's equal to 8 times the sine of 83. Again, if you had these reversed, no problem. I just like to have the variable on the left. Okay, well, now what? Well, you want to get b by itself. It's being multiplied by the sine of 33. So just an algebra principle would be to divide both sides by the sine of 33. I would wait until now to use your calculator. Yeah, you could go ahead and type in 8 sine of 83 and press equals and then do this work and then divide that number by the sine of 33. But it's just as easy to wait until this point now and then on your calculator, and again, your calculator should be in degrees, and that's just true for the whole chapter. Your calculator should be in degrees. 8 sine 83. Don't forget to close your parenthesis after that. Your calculator opens a parenthesis with sine. You need to close the parenthesis and then divide it by sine 33. And that is about 14.6. So the length of b is approximately 14.6. Let me try that again. Now this problem, as often is the case with my software here, did not tell us what to round to. Watch the directions in your book, but I believe rounding to the nearest tenth is pretty common. And we get 14.6. All right, so that's one way of using the law of sines. The other way, or the other concept, if you will, is what if you have to find an angle? Here's triangle PQR, and they give us two lengths. That's lowercase p, lowercase q, those are lengths, and then capital Q is an angle measure. And again, drawing the triangle would be important. If they don't draw it for you, I think you should just sketch one out real quick, draw a triangle. Doesn't have to be to scale at all. They did a pretty good job making this one to scale, but it does not have to be to scale at all. Just draw some triangle, label it PQR, and then label it with its appropriate side lengths and angle measure. And again, what I need to have is this opposite this. If you don't have that, if you don't have both values known, some angle measure where you know the measure, opposite a side length where you know its length as well. If you don't have that, you can't use the law of sines. And you might have a question, well, what do you do then? Well, that would be the next lesson, law of cosines. But if you have this, you want to use the law of sines, and we're going to go sine of 98. Notice again, A, B, and C don't matter. Here I have PQR. It's this angle that's opposite it, and then the side that's, or the angle, and then the side that's opposite. Sine of 98 over 10. Now notice what they're asking for. They want angle R. That's this angle right here. I don't know it because I'm trying to find it. And I also don't know the side that's opposite it, which would be what I would call lowercase r. If I follow just the natural path here, if I just go with what they gave me, what I'll end up finding is actually angle P. That's okay. We'll do it. Sine of P over 7. Because again, we have the use, if we need to, of the triangle angle sum theorem. If I can find P, then I can find R by just subtracting these two values from 180. So here again, you're going to cross multiply. This would be 10 sine of P, when I multiply these two, is equal to 7 sine of 98. Now notice this one's going to solve out a little bit differently too, because you do have the angle as the unknown, different from the last problem. So two steps. You want to get P by itself. It's having the sine taken of it and then being multiplied by 10. So you want to divide by 10. The 10s will cancel. Right now on this type of problem, I think right now is the appropriate time to use the calculator. You have the sine of P on the left. And then it's going to be approximately equal to what I get when I type this into my calculator. 7 sine 98 close parenthesis divided by 10. It's approximately 0.69. Now do leave that number in your calculator. You'll get a more accurate answer when you do the final step, when you take the inverse sine of both sides. When you get the measure of angle P by itself on the left, by taking the inverse sine, again, not of 0.69. 0.69 is a rounded number, but you take the inverse sine of the answer. Reminder on your calculator, that's second negative is answer. Inverse sine of the answer. My keystrokes are second sine, second negative key. And that's 43.9 degrees. Now, again, that's not the answer. They didn't want the measure of angle P. They wanted the measure of angle R. So make sure you're answering the question that they're asking. If I then take 180 and subtract 98 and the answer that I just got, I'll have an answer for angle R, which is 38.1 degrees. I can see they rounded to the nearest degree. Again, watch the directions in the book. They'll tell you what to round to. Okay, the software doesn't do a good job, but our book usually does. So rounded to the nearest tenth. This is the answer they'd be looking for. Thank you for watching.